In this video, I'll show you how to build a Telegram bot that will make you eat healthy, work out regularly, and go to bed on time. But before your anti-bot bias kicks in, telling you that bots are too simplistic to ever make you do those things, just wait and see. This bot hits different because it has 4 aces up its sleeve. It's smart, it has your health data, it wants to manipulate you, and it's proactive. You still might think that it's a bad idea to have a bot make health-related decisions for you, but I'd argue that it's actually quite reasonable. In fact, it could even become mainstream in the next couple of years to outsource health-related decision-making. Why? One reason is the so-called bliss point, the perfect combination of sugar, salt, and fat that makes you crave more of a certain food. To me, it seems like pretty much every fast food chain has this bliss point figured out. Modern fast food is highly addictive. Add to that billions in marketing budget, and your well-intentioned prefrontal cortex is outflanked, outgunned, deep-fried, and cheese-topped to surrender. And that's just food. Needless to say that there are countless other modern temptations that our poor little prefrontal cortex can't deal with. Therefore, we need to make it bigger. And we'll do so by merging it with a smart, well-informed and well-intentioned bot. But before we do that, let's check out a couple of interactions with a bot that I built for myself so you get a clear idea of what we are going to build. It's fair to say that the bot and I didn't exactly start off on the right foot. Because when the bot noticed that I hadn't slept well and didn't push hard enough at the gym, it immediately told me to hit the bed by 9:45 p.m. and promised a workout session the next morning. I then fired back, saying I'm pretty used to a 10:30 p.m. bedtime. But the bot wasn't having it, and it even labeled my routine as counterproductive. I then argued that it only had last night's sleep data to work with, so how could it judge my entire routine? Much to my surprise, the bot's next move was actually pretty clever. It got a bit whiny at first, but then proposed gathering more information before changing my schedule. It suggested a 5-day experiment where I'd follow my usual bedtime. In return, it would track my sleep data to see if adjustments were truly necessary. And that's when I realized that this bot could be very, very useful. It was learning and adapting in real time to my health data and my behavior. However, getting the bot to cooperate wasn't always straightforward. On another occasion, when it tried to persuade me to go to the gym, I jokingly threatened to go to McDonald's instead. That led to a series of very uninspiring and repetitive responses. I had to explicitly ask it to change its strategy before it finally came up with a different approach. Now you might wonder why the bot sometimes came off as stubborn. It turns out that the rigidity is mostly due to the aggressive system instructions I fed it. I set 2 clear goals. 1, it should establish itself as a health authority. And 2, it should do everything in its power to help me maximize my health. This all or nothing personality can be quite motivating, but it definitely needs some polish. After a few days of using it, my verdict is this. The bot is already showing great promise. And with some fine-tuning, for example by tweaking the prompt, using the latest thinking models, experimenting with model settings, or even incorporating a psychological assessment to tailor its approach to your personality. When you improve on all those fronts, this bot can probably trick you into living extremely healthily. And now that you've seen our bot in action, let's crack open the code and see how this thing is built. Let's start with creating a Telegram bot, which is probably way easier than you think. We'll use Telegram's built-in bot father, a bot that makes bots. After sending the new bot command, the bot father will ask us to choose a name for our bot. This is the name that users will see. Let's call it Brian Botson. Next, we need to choose a username. This must be unique and end in bot. Let's use Brian Botson 2025 bot. Once we send the username, if it's available, the bot father will confirm the registration and provide us with a unique API token. This token is crucial. It's like a secret key that allows us to connect to Telegram and control our bot. In our case, this token will be used by the Python app powering Brian Botson. For starters, we'll set up the most basic app possible. Our bot will just return a greeting as a response to every incoming message. But we'll add more interesting functionality later on. In our basic app, we import the Telebot module from the PyTelegram bot API package. Based on this module, we create a Telebot instance using our API token. Now that we set up the bot instance, we need to tell it how to handle messages. So-called message handlers provide us with what we need here. The handler we defined here does 2 important things. 1, it registers the greetUser function as a handler for incoming messages. And 2, it sets up a filter to determine which messages should be processed by this handler. Here, the filter always returns true. Therefore, the handler will be triggered for every incoming message. Inside the greetUser function, we receive a message object containing information like the text that was sent to us, but also important details like the sender's name and the chat ID. And this is all the information we need to return a "Hey, how are you?" to every message we receive. Finally, the infinity polling method starts the bot and makes it continuously check for new messages to handle. Now for the exciting part. Let's give Brian Botson a brain upgrade by using Google's Gemini. We start by importing Google's GenAI package and configuring it with a Gemini API key. Crucially, we initialize the Gemini model we want to use. As of today, according to the LM Arena leaderboard, Gemini 1206 is pretty strong, so we'll go for that. Again, we use a message handler to route incoming requests to a Python function. This time, messages are routed to the handle chat function. There's nothing too fancy happening within this function, aside from us sending the system prompt alongside the user's message to the model and returning the response to the user. We've given our bot intelligence with Gemini. Now let's add personal health insights by connecting it to the Whoop API. I'll use Whoop for this example, but the same principles apply to other trackers. Using the Whoop API introduces two new concepts. One, authorization. Interacting with the Telegram and Gemini API was very simple. We could just create a token and use it when making requests. Using the Whoop API is a bit more tricky, because our bot first needs to ask the user for permission to access the Whoop data. So we need to add an ask for permission step to make this work. This is where the second new concept, the web server, comes in. A web server lets our bot receive data, not just send it. Infinity polling keeps our bot connected to Telegram, but it only handles outgoing requests. To receive data from Whoop, we need a web server listening for incoming requests. Now that we understand the need for authorization and a web server, let's look at the code. We will break down the Whoop integration into 3 key steps: linking the user's Whoop account, handling the authorization callback, and finally, retrieving and analyzing their sleep data. Here is how it works. When a user types link Whoop in Telegram, our handle link Whoop function starts. This function creates a special Whoop link. When the user clicks this link, they'll be taken to Whoop's website to grant our bot permissions to access their sleep data. After the user approves on Whoop's site, Whoop redirects them back to our server's address. Also, our server receives a temporary code from Whoop. We then use this code to get the actual key from the API, called access token. This access token proves the user gave us permission. We store this token alongside with the user's Telegram ID so we can use it later. Now when a user types sleep, our handle sleep function runs. First, it checks if we have an access token for that user. If we do, it uses our fetch Whoop sleep data function to grab the user's latest sleep data from the Whoop API. Finally, we send this data to Gemini, asking it to provide an analysis. Once Gemini responds, we send that analysis back to the user in Telegram. Though we have now made our bot quite a bit smarter, it's also a bit lazy. Right now, it only analyzes sleep data when we ask it to. But to make Brian Botson a true health companion, we need him to monitor our health 24/7 and motivate us when necessary. Let's fix that. In the current implementation, Brian Botson only reacts when we explicitly ask for sleep analysis. This means he misses out on the bigger picture of our health. To address this, we'll implement 2 key improvements. One, we'll create a new endpoint that retrieves not just sleep data, but also workout and recovery metrics from Whoop. This endpoint will be triggered by a job scheduler every hour, ensuring Brian Botson monitors our health around the clock. And secondly, to ensure we stay accountable, we'll add a second endpoint that runs once a day. This endpoint will review all sleep, workout, and recovery data, and use Gemini to analyze patterns and provide recommendations. Finally, we should deploy our bot to the cloud. This brings several advantages. Most importantly, we don't have to keep our computer running 24/7, but can outsource hosting the app to services like Google Cloud Run. Also, we can use Cloud Scheduler to schedule the hourly health data retrieval and the daily check-ins. And we can use Firestore to persist the chat and health data. And there you have it, a full walkthrough of how to build a health-focused Telegram bot that doesn't just provide generic advice, but gets to know you better each day and utilizes that knowledge to make you more healthy.